Everything has a why. You lived 1,000 days you can't recall even one of. Where did they go? You'd guess your baby brain was too unfinished to record anything. That answer is wrong. It has a name: childhood amnesia. Your first real memory probably lands around age 3. And before that, almost nothing. And it's not a gentle fade. Memory doesn't dim smoothly the further back you go. It drops off a cliff. Now, the first wrong assumption, that babies can't make memories at all. That's flatly false, and we can prove it. Picture this experiment. A ribbon ties a baby's ankle to a crib mobile. The baby learns that kicking makes it spin. Days later, shown that mobile, the baby kicks again, remembering exactly what to do. Babies also soak up faces, voices, language, routines, an avalanche of learning. The recording machinery is clearly switched on and running hot, so the mystery flips. The question isn't why babies can't remember. It's why we, as adults, lose what was recorded. Here's the key split. You have 2 kinds of memory: skills and facts and words on one side, specific events that happened to me on the other. You kept the skills, walking, talking, your whole native language, all learned as a baby, all still here. Childhood amnesia never touched them. What vanished is episodic. The I was there, this happened to me memories. That is exactly and only what childhood amnesia erases. Episodic memory has a home in the brain, a curled seahorse-shaped structure called the hippocampus. It's the event recorder and the index. But in a baby, that recorder is still under construction. Its wiring, especially a part called the dentate gyrus, isn't finished. Mechanism 1. An unfinished recorder may save memories in a format the older brain can no longer open. The file is there, the software changed. Mechanism 2, and this one's wild. Neurogenesis. The infant hippocampus is flooded with brand new neurons born at a furious rate. And each new neuron muscles into the existing circuits and rewires them. It's like renovating a library while it's open, reshelving every book at random. And we have the proof in mice. A 2014 study by Eckers, Franklin, and Jocelyn. Boost neurogenesis in adult mice and they forget. Slow it down in infant mice and their baby memories survive. So the very growth that builds the brain overwrites the memories already stored. Forgetting is the price of a fast-growing brain. Mechanism 3. Synaptic pruning. Early childhood mass rewires the brain, snipping away weak connections and disrupting the patterns that held the old memories. But biology isn't the whole story. There's a second problem, a you problem. Episodic memory needs a self, a me that events happen to, a character travelling through time. Scientists call that awareness autonoetic consciousness, and babies don't start with a strong sense of self. The mirror test proves it. Dab rouge on a toddler's nose. Not until about 18 to 24 months do they touch their own nose, realising that's me. And before there's a stable me, there's no main character to pin the story onto. No hero, no story, then there's language. Before you have words and the idea of a story, events aren't filed as tellable memories at all. Studies show it clearly. How well a child can describe an event in words, at the time, predicts whether they'll remember it years later. Words give memories handles to grab. And parents who reminisce richly, asking remember when we did this, help kids build earlier, stronger memories. Remembering is partly a skill you're taught. Here's the twist. The age of your earliest memory isn't fixed. It actually shifts from culture to culture. Maori adults in New Zealand report some of the earliest first memories on Earth, around 2.5. tied to a strong storytelling, past talk culture. Some East Asian adults report later first memories on average than Western adults. So childhood amnesia is never one switch. It's biology, the hippocampus and neurogenesis, plus a missing self, plus missing language, plus culture, all of it stacking together. Now the twist that's rewriting the textbooks. Maybe those memories aren't gone at all. It comes down to two possibilities: never stored, or stored but unfindable. Encoding failure versus retrieval failure. Which is it? In 2025, a Yale team led by Tristan Yates put awake babies in an MRI scanner. The infant hippocampus lit up while encoding specific scenes, and stronger activity predicted what the baby later recognized. Baby brains do record episodes. And in mice, engram studies go further. Travaglia and Alberini showed a forgotten infant memory survives as a hidden trace. Then, Guskiolan tagged the exact cells holding one and switched them back on with light. The memory came right back. The trace was still physically there. So here's the leading new idea. Childhood amnesia may be a retrieval failure, not an erasure. The files exist. You've just lost the key. Think of a hard drive whose data is perfectly intact, but whose file names got scrambled. The memory is right there. You just can't address it. And this is live, unsettled science right now. Erased, or just locked away? Researchers are still arguing it out. And a caution follows from all this. It's exactly why vivid memories from before age 3 are suspect. Most aren't recordings at all, they're reconstructions. Your earliest memory is often a story, assembled later. A family photo here, a retold anecdote there, stitched into a scene that feels completely real. Famous example. The scientist Jean Piaget vividly remembered an attempted kidnapping from his pram. The scratched nurse, the crowd, the policeman. Years later, the nurse confessed she invented the whole tale. A real feeling memory, built from a story. So some of your earliest memories may be things you were told, not things you ever actually lived. Now zoom way out. Maybe childhood amnesia isn't a bug at all. A fast-learning, fast-rewiring baby brain might need to overwrite in order to grow. Because forgetting clears space and generalizes. The baby keeps the lessons, how the world works, language, faces, and drops the individual episodes it no longer needs. So you didn't lose those years. They built you, your language, your attachments, the whole scaffolding of who you are, even though the episodes themselves are gone. So why can't you remember being a baby? Because the recorder was still being built. New neurons overwrote the early takes, and you had no self and no words to file the story. And the few traces that survive may be locked away, not truly erased. But if a memory can be stored and lost this easily, how much can you trust any memory you have right now? That's coming next. Like and subscribe for more.